Welcome back to another video. We are going to talk about the definition and structure of the atom. The atom is the fundamental part of chemistry. It's probably one of the most important things. So it's important that we know what it's made of and how it works and how it behaves. So let's go ahead and get started. We're going to go through three big ideas in this video. We're going to talk about the model of the atom and how it's changed over time. We're going to also focus on Dalton's atomic theory and the four possibilities he put in there. And then we're going to identify three types of subatomic particles. So three big ideas throughout this video. But first, let's actually give a definition to an atom. So an atom is the smallest particle of an element that retains its identity in a chemical reaction. Basically, what that means is it's the smallest particle, and it'll keep its identity, kind of like what Jason Bateman wanted to do in Identity Thief when it got stolen. But for us, it's basically an element. So atoms are small particles of elements. And I use tungsten because tungsten is an element on the periodic table, number 74, but it's also my favorite. So something maybe you should remember, and it might show up sometime later. Hint, hint. Okay. So tungsten is my favorite element. There are about 114 different elements that all have their individual atoms. But how do we know about this stuff? How did we figure out what an atom was? Well, it's all started with this guy named Democritus. He was a philosopher back in the day, very, very back in the day, if you notice the dates. And what he said when he studied the atom was that atoms are indivisible and indestructible. So he was basically saying they are the smallest things in life. Okay? So atoms were the smallest things in life. That's what he thought back then with his knowledge available at the time. Remember, it was really back in the day. It was very, very back in the day. Well, a long, long time later, John Dalton came along back in the 1800s, and he kind of said, cool bro, but now I have this thing called the scientific method, and I theorized, and he came up with four things. The first thing he said was that elements are composed of tiny indivisible particles called atoms. That was keeping with what Democritus was saying back in the day. He thought that atoms were the smallest part of life in general. The second thing he said, something that he added though, was that atoms of the same element are identical. So atoms of tungsten are identical to each other, but atoms of different elements, like carbon and tungsten, they would be different atoms altogether. The third part of his theory was that atoms of different elements can be physically mixed together or chemically combined in simple whole number ratios to form compounds. So basically they can go through a physical or chemical change and be mixed together or combined through physical or chemical means. Okay, kind of what we talked about with chapter 2. The fourth thing he had in his theory was that chemical reactions occur when atoms are separated, joined, or rearranged in different combinations. Okay, that is the key idea with a chemical reaction. We can see chemical reactions, we can talk about energy transfer between them, but the key idea is that chemical reactions are when atoms are separated, joined, or rearranged. Okay. The caveat to that is that atoms can never be turned into another element. So I can't take tungsten and make it into carbon. Atoms of tungsten cannot be turned into atoms of carbon. They can be combined with each other, but they can't be turned into another one. That's the only sort of caveat or law of nature that we have. But after Dalton, so while that was going on, there's this guy named J.J. Thomson, and he was also studying the atom, and he's like, that's pretty cool, but with my cathode ray, he actually found an electron. So he split the atom up, he like broke it apart, and he found an electron in there. And he's like, look at this, an electron. And he actually won a Nobel Peace Prize for it. And in 1906, he won the Nobel Peace Prize because he found out that Dalton was pretty wrong. Dalton was wrong, and that atoms can be divided into its smaller components, and one of those components was the electron. So when J.J. Thomson found that out, there's this whole rush of other scientists scientists trying to come in and do what J.J. Thomson did and sort of find other parts of the atom, because we know it's not the smallest thing anymore. And so Robert Millikan, he was researching around the same time as Thomson, and he was like, yo, T-Dog, my oil drop experiment found the charge of your electron. So he found that the electron has 1.60 times 10 to the negative 19th coulombs. That's the charge, the weight, or weight of the charge, I should say, of an electron. And that was pretty awesome too. And so J.J. Thomson was like, thanks. And then there's this other guy named Eugene Goldstein, and he was kind of like, look what I found, a proton. Proton is a positively charged thing in the atom. So now we have two things that the atoms are composed of. So two smaller things that the atoms are composed of, an electron that J.J. Thomson found, and a proton. And then another guy named James Chadwick, he was like, me too, I found something. I found a neutron, and a neutron was neutral. So now there's three things, a proton, an electron, and a neutron that the atom is composed of. So we now know it's not the smallest thing anymore. And that's when Ernest Rutherford sort of compiled everything, and he's like, guys, my gold foiled experiment told me the nucleus contains the protons and neutrons. So we started to structure the model of the atom after Rutherford did his gold foil experiment. So overall, throughout time, our current model is what we call the electron cloud model. And it's basically a central nucleus with protons and neutrons in the middle, and then a cloud with the surrounding electrons around it. Now this is not to any scale, so keep that in mind, but it's how we organize the current model of our atom. We call it electron cloud model. We'll talk about that more in chapter 5 because we're going to deal with specifically electrons in chapter 5, but this is the model of the atom that we have now throughout all the research done by all these cool scientists. If you have any questions, let me know. Otherwise, have a wonderful night.